Hi everyone, good afternoon. I introduce myself. My name is Jesus Garcia. I am one of the members of team number 4. My team is made up of Arturo Macias, Catherine Azua, Guadalupe Lugo, and Alfredo Castro. Today we will be introducing you a video of your explaining of what linear programming is well. The next thing to do will be explaining an example of linear programming.
Linear program exercise. 600 grams of certain drug are available to make large small pills. The large ones weigh 40 grams and the small ones 30 grams. At least 3 large pickups are needed and the last twice as small as large ones. Each large pick provides a profit of 2 euros and the small one of 1 euro. How many pills of such class have to be made for maximum benefits? Every station has a problem. What may be to maximum benefit asked it's a problem of maximization, not minimization. Be careful with that when identifying the problem that is what being asked.
Well, we're gonna start with the basics here and just talk about identify variables. So we're trying to figure out what values of the variables um, will help us to maximize or minimize something. In the problem, it has given us a big clue as to what the variables are gonna be. In other words, we need to find out the number of large pills and we need to find out the number of small pills. And that will give us the profit. So we're gonna let X for the number of large pills and we're gonna let Y for number of small pills. Well, the problem is about getting the maximum profit. You have to sell the pills and get the maximum profit. In this case, we need to find out the maximum profit, so that will give us a function that we need to maximize. In conclusion, it is a maximization problem.
Once the area of feasible solution with the point of feasible solution is already taken out, we will have chose ones that will be the optimal solution. We will know it's be calculating using the objective using the objective function f x y through x more y. We substitute and consider the point where x like 5 and y like 12. Therefore, the objective function where we 10 more 12 is 22, being the optimal solution. The first restriction tells us that x must be larger than and equal to 3. The second restriction through x greater than of equal to y, where it's necessary to substitute and place a point. The third and last restriction says 4x more 30y is less than or equal to 600. Once the graph is plotted, the feasible solution area is obtained.
Finds the plot. First will be often the points to be plotted with the following restrictions. The first restriction tells students that x is greater than or equal to 3. The points are 3 and 10. The second constraint is 2 times x, which is greater than or equal to y. X equals 10. 2 for 10 is equals 20. The points are 10 and 20. Finally, restriction. 40x times plus 30 times j is greater than or equal to 600. X equals 0. 30 times j equals 600. J equals 600, comma 30. J equals 20. X equals 600, comma 40. Finally, x equals 15. The points are 15 and 20. Now, we continue using the previous points in this graph. We have the point 0 and 10, the point 15 and 20, the point 3 and 20. Finally, we try the points. Thus, we obtain the fields of a sum. This area will help us to have the maximum performance. We will take into account the following points: the point 3 and 16, the point 6 and 12, the point 3 and 6.
Hello everyone, my name is Jesus and I will explain the final table once the checks have been made. It's possible to obtain the most optimal solution to maximize the production of the tablets. Well, to deter what is so the manufacture three large Philips and 6 small Philips on the for a price of the 12 euros.
Thanks for watching. See you.